All right. So it's 4:30. I just want to make sure that everybody here is here for the Noobernetes 101 course or talk, and not for like an Istio talk or something advanced, right? Cool. So welcome, everybody. This is when we initially thought about this talk, we were thinking we'd do it to our 10 most intimate friends, and we have a lot more intimate friends, so that's great. My name is Karthik. I work at Oracle. I am not a DBA. Thank you. Most conferences I go to, I always get like a too normal form question or something like that. Oracle apparently now is a cloud company, and I actually work on a team that's called Cloud Native Labs, and that's at cloudnative.oracle.com. I wrote a course on LinkedIn Learning, or lynda.com, called Learning Kubernetes and a bunch of other courses. And that's kind of what we're going to talk about today. I got a lot of questions from it, so we kind of wanted to put together a topic. I'm from Austin, Texas. I run DevOps Days Austin over there, and a bunch of other other conferences as well. And I've been in industry for a while, worked at a bunch of companies.
Hi, my name is Neependra Khare. I run a company called CloudYuga in Bangalore, India. I authored the intro course on Kubernetes on edX, which is CNCF official course for Kubernetes. If you have taken that course, that's authored by me. And I have written a book on Docker a few years back, and run a Docker meetup group in Bangalore for the last 5 years. Yep, I think you can explain.
Cool. So we got some questions for y'all, because we're going to be doing a lot of talking. So we want to get some audience input first. So tell us a little bit about yourselves. Like, show of hands, how many folks here are developers? Good number.
Wow.
What about operations or DevOps? It's like almost like a half and half split. What roles am I missing? QA maybe, or?
Silas.
Sales, okay, cool. And that's totally valid. What else am I missing? Anything else? Product manager, okay, cool. What about containers? Do you all speak containers? How many folks already know about Kubernetes today? Would you classify yourself as a noob cube? You don't know much about Kubernetes, okay. What about, do you all run Kubernetes in production? Show of hands. A few, okay, cool. And then, is this your first KubeCon? Awesome. That's what I was wondering, because I was like, you know, why are folks like coming to this talk? And I was hoping that there would be a lot of like questions about Kubernetes and first KubeCon, so a lot of those kind of sync up. So our goal today is we're going to talk through some of the most like common Kubernetes questions that we get. And you know, we get a lot of emails, LinkedIn messages, like a whole bunch of like different ways that people kind of contact us about Kubernetes questions, and we're like, hey, we have like almost like a cheat sheet of things that people ask us. And we want you, the goal is for y'all to leave here with more answers than questions. So for whatever reason you don't get what you're getting from the presentation, please come talk to us after. We're happy to talk till whenever you'll want to talk about stuff, because honestly, we just want to help. So with that, we'll go into our first question.
Yeah, why do we need containers when we already have VMs? That question we get so often. So generally, when you kind of start with containers, people say containers are lightweight VMs, which we hear, and it's good for analogy. But if you look at, technically it's not true at all. So if somebody says this containers are lightweight VMs, it's okay to kind of get started. But if you look at the difference between the VMs and the container, you can see there for run each VM, you would have a hypervisor, which would kind of get you some CPU, memory, and so on, and then you put your OS on top of that, and then you put a VM or an application on top of that. That's how the VM work would work. Basically, you have host OS, hypervisor, and emulation, and then you have the application on top of that. But in terms of containers, you have the host OS, your application runs directly on that. So you have just a host OS, an application on top of that. So when somebody says that you are going to run a container of Ubuntu, Fedora, or CentOS, they are just considering the user space of that distribution. There is nothing called Ubuntu container runs on your Fedora container, which runs on a host OS. That's something which we have to kind of very careful. So why we need containers? Lesser cost, more density. So you can, if on the same hardware, you could run 10 VMs. Now with containers, you can have 100 containers on the same hardware what you used to have. So it will save cost. Once a developer develops an application on his laptop, the same application goes to the production and the dev and so. So all that kind of benefits you get with the containers. Now we are hearing about some lightweight VMs in which you can say, okay, we can run a VM, very lightweight VM, and in this we'll put one container on that. So one container, one VM, that kind of things are going on right now. And you might hear the terms like Hyper-V containers on Windows, Kata containers, AWS Firecracker. So things are evolving there. So maybe we'll reach a point where you'll just have one container, one VM kind of combination where you get full security of VM and just run one container on that. Yeah. Mm-hmm. So the next thing, once you kind of understand about VMs, then where you would deploy your Kubernetes cluster. So do you want to say, I want to deploy on-prem, or should I go on cloud-hosted environment? Where should I put my Kubernetes cluster on? There's some differences here between the on-prem and on the cloud-based one. So with on-prem, you have to kind of manage everything on your own, first of all. You have to do the capacity planning ahead of time. So how do you scale our applications? So once you kind of say, I'm going to run, let's say, 5 copies of my application. If my load goes beyond my expectation, I'm going to scale my application. But you can only scale the application in on-prem. You cannot scale the VM or underlying infra on its own. But on the cloud-based one, you could kind of scale the underlying VM on the go. So if you have 5 machines running in your Kubernetes cluster, you deploy more applications, which needs more resources. Just go and deploy one more VM, add to the cluster, and so on. Other than that, you can, once you expose the application to the external world, it's a bit difficult task to expose the application to the external world if you're on-prem. But on the cloud, you have features like LoadBalancer, Ingress, and so on, which will help you deploy the applications very quickly on the cloud and so on. Of course, to attach data to your application, so whenever you run an application, you would put some data into that. And if you kind of manage the storage on your own, it's a bit difficult to manage on-prem, but it's not impossible. Of course, you can have softwares which are available now, which can create a cluster of the underlying storage within your on-prem, and you can use it. But on cloud, it's much more easier. Yeah.
Makes sense. And so since I'm a cloud guy now, because Oracle's a cloud company, let's talk about the self-installed Kubernetes versus managed Kubernetes services that are becoming super popular today. So self-installed, if this wasn't already clear, it's it's basically where you have to do all the installation stuff yourself, and there's a bunch of different ways to do that. On AWS, people kind of already use KOPS, Terraform. There's like various Terraform installers that you can use across different cloud providers, etc. The key thing here is you, as the person installing all of this stuff, like you are 100% responsible. Typical use cases of this is like when people do this on-prem, you do all the installation and all the management as well. I put a small diagram in there, so that basically just says that you're kind of like on the hook for most of the stuff. Software installs, backup recovery, high availability, scaling, app management, like everything. If you're on the cloud gives you like server provisioning and rack and stack, etc. Now, so this is a great analogy because I love 80s cartoons because I'm an 80s kid. So I'm like, you're like She-Ra or He-Man, where you have all the power in the universe to do whatever you want to do. So that's kind of like a good analogy for a self-installed. Now on the managed side, you're kind of offloading a bunch of things to the cloud provider. So in the fully managed service that you can get, we have GKE, EKS, Oracle has Oracle Kubernetes engine, DigitalOcean just announced one this week. So in that case, your cloud provider manages like what they call the control plane. And the control plane basically manages your Kubernetes instances. What you're responsible for is your data plane, or rather like the nodes that you're running your applications on Kubernetes. And so you're kind of offloading the things like high availability, scaling, et cetera, to the cloud provider, but you're kind of managing the nodes that you're running all of the stuff, like all of the deployments and applications that you have as a Kubernetes thing. The benefits of this, it's a lot quicker to get started. You're not kind of like dicking around with config files to get Kubernetes up and running. You're like running within like half an hour or whatever, after you start your AWS console or whatever. Lower risk, and you're kind of going a lot faster because if something goes wrong, just kill the cluster, bring up a new one. This is analogous, that sounds right, to VOLTRON, which is another 80s cartoon. And it's like VOLTRON is formed by the 5 lions. So like teamwork is dreamwork, right? I didn't get any, that was my last joke slide. Everybody laughed. All right, whatever. So let's kind of like talk through self-managed versus self-install versus managed Kubernetes and what the differences are in here. So if you had to choose, the pros of a managed service is like you can offload all the control plane management to the provider, because like you don't care about that stuff. Just let the provider kind of handle it. You spend more time doing the things you really want to be doing. Like you want to be building applications, you want them to run on Kubernetes, so you're actually spending time doing that. And there's a lot less maintenance headaches. So a couple of weeks ago, or I guess it was last week actually, where the vulnerability was announced, and basically all of the service providers went back and like fixed the Kubernetes instances. That's something that you didn't have to do by yourself. So there's a little bit less maintenance stuff that you have to worry about. The problem is that it's not fully customizable. So a lot of times app providers or cluster providers take, they're not fully customizable. So like if you have specific networking things, so let's say you really want to use some specific kind of network or specific storage and stuff like that, you might not be able to do that. And occasionally there's hidden costs as well, so beware of those. So if you want to look at this in a recipe format, basically if you're cloud, use the managed service provider to start with, especially for folks that are new, like do that and then figure out what your use cases are, play around, get started, and then if you're like, hey, you know what, this actually doesn't solve my needs, then go back and actually do the self-install yourself. Pivot to the self-install. So moving on, at this conference even, so like we talk about Kubernetes and there's a lot of buzzwords associated with that. We're like, do I really need microservices when I'm doing CI/CD or when I'm doing Kubernetes? Do I need a CI/CD pipeline? Like where does it kind of end? Do I need Istio? Like blah, 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 right? So let's break this down just a bit. So Kubernetes is kind of this analogy where it's like, there's this popular saying where you have like a bunch of blind men and an elephant, and they're like touching the elephant, and they're like, wait, the elephant's trunk feels like an elephant. So like everybody's kind of saying like different things, and if you read blogs and stuff about Kubernetes, like people say a bunch of different stuff. But really, in reality, Kubernetes is like a very open platform. Like it plays nice with like everything and everything around. The challenge here is like in your role, you can kind of decide on the priority of what you want to do. So if you don't want to start with CI/CD, that's okay. Like worry about that on day 2. If you don't want, like you have to use containers, but if you don't want to do specific things, you can offload that. So if you were to ask me for a specific strategy, and you're coming from either a dev side or an ops side, it doesn't matter, just make sure you're planning for microservices. You don't have to build microservices on the first day. You can take your monolith, put it in a container, run it on Kubernetes, and that's all right. I'm telling you, that's all right. A lot of people actually do that today, so it's not like, you're not crazy if you want to do that. But from a collaboration standpoint between your devs and ops teams, like use the YAML that you kind of have to collaborate with. I know it kind of sucks, but like it actually is a language that you can use to collaborate between teams. There might be something better later on. From a CI and CD perspective, use CI to build your images for your containers. So that way, when you're like making your application updates over and over again, your like CI system is taking care of building it, testing it, also building your images. And then once you've done all that, then decide for a deployment strategy for Kubernetes. So you don't kind of have to do all of that stuff up front.
Thank you. So we have a cluster running up and running, and we know how to deploy some applications. There are different ways you can deploy the applications into Kubernetes. Of course, everybody heard about YAML files. You can write a YAML file for your application. You can build a deployment or service file, and then you go deploy the application on the Kubernetes cluster. There are different tools now has been built which you can use other than YAML files. Some of them can just take directly a code, and with that code you can deploy the application in Kubernetes. So the tools like Draft and Scaffold are the tools where you can just point them to your Git repo, which can take your source code, configuration files and so on, and deploy the application directly on the Kubernetes cluster. With the manifest file, which kind of the YAML files, you can work with them further with the tools like Helm, which is like a chart. So you can create a chart, and it can use your YAML files as a template. So you can have a configuration for your application. For example, you can say, for this application, I want to have 4 GB of RAM assigned to it. I want to use 3 replicas to that. That you can put into a config file, and then config file can be used to deploy the application using the YAML files template. Similarly to case monitor and customize, they would take your YAML files, and you can kind of decouple your configuration with the YAML files and then deploy it. So these tools can be used for deploying purpose application on the cloud or on the Kubernetes cluster. Then we have a GitOps technology used very often with Kubernetes now. So GitOps in Kubernetes world, you can say it's kubectl plus Git. So what you do there is you kind of have your configuration pushed into Git. You do a Git commit, and that Git commit triggers a kubectl update or create or whatever command on your underlying infra what you have. So the tools like Argo CD, Jenkins X, vWorks, Flux, and so on, they kind of the tools which you can use for doing the GitOps in Kubernetes. So we have deployed the applications. Now, what are my ways to expose the application to external world? So I have an application running, I have a service running. Now, how would I access the application within the cluster and with outside the world? Let's see them. So quick architecture of Kubernetes. As you can see here, there's a master or control plane, and when we have these worker nodes. And in each node, including the master node, we run something called as kubeproxy. The kubeproxy is a program which allows the external access of the application to the cluster. So it's not happen that your application access is happening by the master node. Master node is just for the control purpose. Your application access happens directly by the kubeproxy or the worker nodes. The kubeproxy can be on the master node as well, by the way. So with that in mind, let's look at one of the type of the service, which is like cluster IP. In this case, the cluster IP service is available only inside the cluster. So you kind of bind few pods together and create a service, and that service IP what you have here, it's available only inside the cluster. So we have here service blue and service green, and there's some IP. They can run, they are inside the cluster only, they are not outside the cluster. So you are with cluster IP you are accessing within the cluster. And a node port, the next type service type called node port. Now what's happened here is if you have run the docker command, docker container run -p 8080:80, which means you are exposing port 8080 of the host with 80 of the container. That's on one single node. In Kubernetes, when we expose with node port, what we are doing is we are exposing a port on all of the nodes. So like in this case, we have the blue service and we have a node port there. So whatever the port number we are going to use for the node port, it is being exposed on all the nodes, the same port number. So you can hit any of the node and your request get forwarded to the service. Like in this case, if you can see the third node, we don't have any pods running there, or they have a blue pod not running there on the node 3. So even if my request come to the third node, the request will go to the service from the kubeproxy. So there is no need to run the pod on the node where accessing the services. So with service, with the node port type, what you can give to the customer, you can say, you can maybe want to give to your customer a node IP and the port number. You give it to your customer. Might be okay, would be work. But what happens if the node goes down and the URL which you're going to the customer is no longer valid? So it's good for exposing service. But what you do next is you're going to use something called as load balancer. So what you do in this case is you're going to load balance the application or access from your cloud provider. So when I say expose my service as load balancer in my Kubernetes, Kubernetes will talk to my underlying cloud provider, for example, AWS or Google or Azure, and it's going to create one load balancer IP for me, or load balancer CNAME, whatever you can think of. And when I access my load balancer IP or the name, my request gets forwarded to any one of my node. So I'm doing a load balancing two-way here. One is at the node level. So I do that load balancing. Once I come to the node port to the service IP, then I do the load balancing at the pod level. So that can be done here. What's happening here is you're going to create a load balancer per service, which means if you have 10 services, you're going to create 10 load balancers. It's expensive, non-scalable. Then you move to Ingress. So what happens is instead of exposing all of our services as load balancer, what you could do is you can create a kind of a Ingress controller in a cluster, and that can be exposed as load balancer. So for all of your websites name or the like a path-based thing, you give the same DNS name to it. And with that, everybody comes to the Ingress controller, and from there, they can come to the service and so on. So like in this case, we have a load balancer for a given service. So when we hit the load balancer for the Ingress controller, it goes to the node port. From there, we'll go to the Ingress controller pod, and which can directly point us to the right pod behind the scene. So it's Ingress, and other than that, there are a few other ways to expose the application, which is like extension of Ingress object, like application load balancer from Amazon's NLP and Google Cloud load balancer. So with that, you can take Ingress to the next level, and you can kind of deploy it, access the application from there.
So one thing I wanted to like touch on real quick, the service question is probably the question we get the most often. And I kind of wanted to touch on one thing real quick. So cluster IP is available inside of the cluster, so you can't see that outside. Node port, most people kind of use this when they're playing around with Kubernetes and you want to run something really easily in Kubernetes, you kind of use a node port. Load balancer, when you're running on a cloud provider or somewhere external, you end up using a load balancer, ends up being really simple. The drawback with the load balancer is, like Neependra said, you're paying for it. So as a cloud provider, I would love for you to use 10,000 load balancers because I can charge you like 10,000, how many ever dollars like a single load balancer is. And that's kind of where Ingress comes into play. Ingress allows you to do a one-to-many kind of mapping behind the scenes. So you can use one load balancer, and then you can have like a bunch of different things kind of fanning off of that. So let's move on, and let's talk about, we touched on some of the details in Kubernetes, but at this conference, we kind of talk about serverless, server mesh, Kubernetes, like a lot of jargon, right? So where does all of these things kind of play a role in this ecosystem? So if you talk to a lot of folks, you get this cop-out answer where people are just like, well, it depends on your use case. You use Kubernetes, like it depends on your use case. You want to use serverless, well, whatever your use case is, right? But the real answer is, the thing that you should ask yourself when you're wanting to use Kubernetes is think about like what problem does Kubernetes actually solve, either for your team, your organization, whatever. A lot of times, we hear like when users come to us, they're like, hey, my VP came to me and said, we're going Kubernetes. And we're like, okay, well, like what does that mean? But like the VP is telling me like I got to do this Kubernetes thing. But a question that you can ask back to somebody in your organization is like, okay, so we're all for it. Let's make sure we're doing it for the right reason and what problem does it solve? And then are you actually ready to manage a new platform? And then kind of consider the use case you're working with. With service mesh specifically, in my opinion, it's a subset of Kubernetes. So if you're going to use a service mesh, so if you're going to use something like Istio or Knative or whatever, you're going to be managing Kubernetes behind the scenes anyways. So as a first step, make sure you kind of know like how to Kubernetes from an operator level. and learn how you use Kubernetes in production first. Because if a node goes down or etcd goes down, all of your Istio stuff will also go down at the same time. So like, make sure you know how to do the Kubernetes stuff first. All of the new stuff with service mesh it's like brand new. There are a lot of like unicorn organizations using service meshes, but what I would say is build it with caution. Don't kind of over-engineer a lot of the stuff with it. Just kind of start simple and then kind of go on, because that field will evolve. Like Kubernetes releases every 3 months, and that's just like little features every now and then. It's not like a year ago where things were drastically different. But you know, there's a lot of change on the service mesh side, so keep it simple. With serverless specifically, serverless is really, really good for small teams or specifically for developer teams. A lot of the folks that kind of use it today, you know, they use it for processing, use it for end APIs, et cetera. You don't have to worry about infrastructure at all with serverless. And so like, you don't have to worry about like cluster management, nodes, like none of that stuff. So it's a little bit simpler from a usage perspective. And it's a better fit for teams that have like use cases that don't require orchestration and things like that. A good question to ask yourself or your team is like, figure out why you can't use serverless versus why you can use serverless. And you know, that's provided you already don't use Kubernetes today. And if you can't find a good answer for like why you shouldn't use serverless, you probably should be using serverless. So moving on to another thing we get in Kubernetes at all, and that comes to users. Like how do you authenticate, how do you authorize, and that's something that I kind of get a lot. And also like how do you scale teams for Kubernetes. So basically for authentication, there's a bunch of different ways. And this really depends on like what you want to do with your organizations. Smaller organizations might pick like a client cert or static token file or whatever. Larger orgs might do like OpenID or webhook mode. So it really depends. The docs are pretty good, so take a look at those. The only caveat on this is you got to pick something. Like don't go and not pick anything. Don't go and not pick anything. Oh, okay. Yeah, that kind of makes sense. There's a double negative sentence, but because if you don't pick anything, you can do authorization, and authorization is just as important as authentication. There's a bunch of different ways, once again, to do authorization, but really like the two big ones here are ABAC and RBAC. And ABAC is attributes-based control, RBAC is role-based access control. There's also webhook mode in here as well. ABAC, not a lot of people use that anymore, so if you really want to use ABAC, like make sure you are picking that specific thing for a specific use case. Most folks kind of use RBAC today, so it's become like the de facto standard. And it's based on like roles and role bindings inside of the Kubernetes ecosystem. You can also use multiple authorizers together, like cloud providers kind of do that behind the scenes where you have to use, like Oracle's identity management and then also RBAC behind the scenes, but it can get a little bit confusing, so just keep it simple. And when it comes to scaling, there's kind of like two ways, or like team management, there's kind of two ways to do that. The old way used to be namespaces. So people would use namespaces to kind of manage different teams. So if you, like one, or not the different teams, but like you can do different teams, or your dev, test, and prod can be on different namespaces, but you're using a single cluster for that. With managed providers, cluster creation and deletion has become really easy. So you can almost create like separate clusters for all of your work. So you can have like a cluster for dev, a cluster for staging, cluster for production, et cetera, whatever. And we end up just treating the clusters as cattle and not pets. So like you might just delete nodes at will because you want to. And so moving on, let's look at the best way to kind of handle secrets, certs, and credentials and whatnot. Credentials and secrets. So this might seem kind of basic, but whenever you're storing sensitive data, always store that using Kubernetes secrets. When I mean sensitive data, it's like database passwords, username passwords, that kind of stuff. If you want to kind of level up on that, there's a new thing called the experimental encryption provider config. Take a look at that, because basically when you store an etcd as a secret, I believe it's just base64 encoded, so it's not really encryption, it's just encoding. So if somebody tries really hard, they can kind of get to whatever the values are. So you can use the experimental provider to actually encrypt it in a different way.
Thank you. So we talked about installing, authenticating, and so on. Next step is how do you store the data in Kubernetes cluster? So you have an application running, and you want to make sure that data what you're storing in the pods or in the containers there, it is stored in a persistent storage. It's not that your pod restarts and your data is just gone. So in a pod, you can have multiple containers, and we attach a volume to a pod, and then we can say a given container, or we can mount that particular volume at a different location on different containers. For example, a container one can say I'll mount on /mnt, while other one would say I'll put on /tmb, whatever. So you attach a volume to a pod, and each container can decide where they would like to mount the volume. With that, we can have different drivers using which we can attach the volume to our pods. Empty dir means it's like a scratch pad. If the pod dies, it will die away, which means you shouldn't use in production at all. It is good to give you the analogy or kind of a signature of a volume, but it's just going to die as your pod would die. Host path is something where you store the data on the host path or on the host where the pod is running. So for example, you can say my /mnt data on the host system is the source of the volume, and when I mount in the pod or in the container, it will be a different location. So your host actually hosts the content what you have. NFS, I think you know. Then we have these cloud providers like we can have storage on AWS, GCP, and so on, which I could assign to my volume directly on the pod. There's something called as persistent volume claim. So a kind of different kind of a driver. Now in this case, what's happening in the previous case is when I'm creating the volume, as a developer, I am responsible for creating the volume on the cloud. So I want a storage of 10 GB. What I would do as a developer, I have to go to the cloud provider and say, okay, get a storage creator, then attach to it, which I don't like it as a developer. And similarly, the ops person is not going to give the permission to all the developers, okay, go to the cloud and do something, right? So for that purpose, we kind of built a driver type called persistent volume claim. So as developer, I would just say I want a storage of 10 GB or 5 GB, whatever I would say. And that particular request would then go to my cloud provider or my operations team, where they would have a pool of storage and which I can attach to. So what I could do is I could even attach this volume as a static volume provisioning. What I meant by that is your ops team would create a pool of storage. For example, if you have ops team can create a storage pool of like 5 GB, 10 GB, or 12 GB, whatever it is. And as a dev person will say, I want 10 GB one. And that way, you can get the mapping of 10 GB volume attached to your pod. With dynamic volume provisioning, you don't create the volume ahead of time. What happens is, as you request, the request will go to the respective storage or dynamic volume provisioner driver, like a storage class there. So we have a storage class in between. So as an ops person, I would create a storage class. For example, I would say storage class name called Platinum. That Platinum goes to Google Cloud and creates some storage. So I'm going to not create the storage ahead of time. As I get a request from the developer, I would pass it to the storage class. The storage class would decide which particular backend I want to use and create the volume from. So once I have this kind of storage, I could just use it directly in my pod and so on. There's something called stateful sets as well. So you could with the stateful set, you can deploy the stateful application in the cluster, and you can assign the storage with the storage class and so on. So yeah.
Cool. So where do we go from here?
Yep. So there are top questions what we got, but if you have more, we can take later. I'll give you a few pointers. We'll give you a few pointers. Then where we go from here. So let me just open that link. Sorry. So there's a course on ADX from Linux Foundation, which covers the basics of Kubernetes. If you have not taken it, please take that course. I authored this course for Linux Foundation. And this course has been taken by more than 50,000 people around the world. So if you are brand new to Kubernetes, I would highly recommend you take this course. And and there's documentation, of course. You can go and check it out. And we also, as a company, CloudYuga provides training. And we have built our training platform, which can be accessed by the URL which is given there. We have a booth here. If you want to come down and talk more and take a demo, please drop down to our booth tomorrow, and I can show you the demo and more stuff.
And then from my end, Kubernetes is all about community. So if you're not already a part of the Kubernetes Slack, go ahead and join that. It's a great way to there's different channels. You can ask different questions associated with that. And then from an Oracle side, I work on the Cloud Native Labs team. So you can check out cloudnative.oracle.com. There's a blog. And then there's also different kind of, we have a learn section where you can put different kind of things where you want to learn Prometheus or whatever. There's training stuff for that. So with that,
there's one more, the forum called Discussion Kubernetes channel is there, or I think Kubernetes Forums. Or you can just go to Discussion Kubernetes Forum there. You can ask questions there as well.
Cool. And with that, thanks for coming out. If you have questions, come talk to us.
Thank you.